Hello, this is a video on finding the inverse of a 3 by 3 matrix, and I'm going to take you through the principles in the first part of the video, and then we'll look at the uses in the second part. We've already looked at how to find out the inverse of a 2 by 2 matrix, in which we repositioned the coefficients there, but we also found this determinant, this AD minus BC. And if we just look at where that comes from, well, that's AD, take away BC, yeah? So we've got this cross multiplication going on, and what we're going to see is that that's essential to the whole thing. And I'm going to use this example matrix and equation in these videos for solving. Okay, let's do it algebraically. Here I've got three equations with three unknowns, three simultaneous, yeah? And how would we go about solving that? Well, we normally go through by eliminating one of the variables, and then moving on to, so we have three variables, then to two, then to one, yeah? And how do we do that? Well, we do that by cross multiplication. So if I took the first equation and the second equation here, first equation and second equation, what I do is effectively cross multiply by the x coefficients if I'm eliminating the x. Yeah, so I do that multiplication. Yeah, so I'd have 3 times 5 give me 15, and 2 times 4 gives me 8, and then I do this cross multiplication there, and I would create two equations. Here they are. Here's my cross multiplied equations in effect. Both of them have got coefficient of 12 for the x, which eliminates that when I take one away from the other. So now I've got an equation in y and z, and I can do the same thing with the first and third equations and do the cross multiplying by these coefficients, and as a result I get same coefficient 6x and 6x, which cancels out when I subtract, and now I've got an equation, another equation in y and z. So what I've done is moved from having three equations in two unknowns, now I've got two equations in two unknowns, and I do exactly the same thing with the cross multiplication here, and now I can eliminate the y. There we go, it's 238, and I get left with a single equation with a single unknown, which I can solve by just dividing through by this coefficient, 378. Bear in mind that 378, we're going to come back to it. But we found there that z equals 3. So what we've done there is loads of cross multiplications, and those cross multiplications are actually determinants. And that's what drives the whole of this process. So let's automate that process in inverting the matrix. The first thing we've got to do is find the determinant. Well, we find the determinant by starting by a sort of symmetric process. So we're going to start top left, and I've got our value there, which I've got to multiply by other numbers. This is called the factor. And if I cross out all the numbers there in the row and column of A1, then I'm left with this minor matrix, B2, C2, B3, C3, and I can find the determinant of that by multiplying it out. And then symmetrically I have to do the same thing for the middle column, there we go, and therefore I've got that minor matrix to find the determinant of, and then I've got a final column, and again if I'm going to multiply this factor by that, the determinant of that minor matrix there. And the other thing I have to look at is signs of this, and I'm going to go plus minus when I start adding them together, because if you think about it, we had AD and then we had take away BC, so the sign was negative, and if we went again it would go positive again. So let's do this for real with the matrix we've got above. So first thing I'm going to do is the left hand column. My first coefficient top left is 3, so I'm going to do 3 times, having crossed out the values that I don't want. I'm going to find the determinant of this minor matrix here, so that's 5 times minus 4, take away 6 times minus 10. Yeah, that's what I've got in the bracket. That lot is 40. So my first contribution is 3 times 40. Do the same thing with the minors for the middle. There we go, so I've got 2 times the determinant of this minor matrix, which is 4 times minus 4, take away 6 times 2, that's the bracket, so that was minus 28, and that's 2 times that. And finally my third column, crossing that out, I've got 1 for my coefficient. I've got this matrix here, find the determinant of that, 4 times minus 10, take away 5 times 2, that's 50. So I've got 1 times 50 there. So I've now got my 3 components, but I have to deal with the sign issue that I talked about earlier. So a bit like AD would be positive, my BC would be negative, and my next one, if I had one in EF sort of thing, would be positive. And if I add those together, I get 126. Now, how does that relate to the 378 we saw earlier? Well, 378 is 126 times 3, so that's the determinant times by one of the coefficients. I think in this case it's the 3. So we now know how to get a determinant. And we're going to use the similar method to sort out the actual values of the components in the matrix. And we do that by, for each corner, so for top left here, I'm going to find the minor matrix for that corner, and I'm going to find the determinant of it. That's what the red lines mean. So I do exact same sort of process we just did. I want top left, so I can circle my 3, cross out all the numbers in that row and column, and I'm left with that minor matrix, which is the minor matrix for which I'm going to find the determinant in the top left. If I wanted the one in the middle, let's go straight here. Let's say I'm looking for the middle coefficient. There's the 5. I'm going to cross everything out. I'm not multiplying by the 5. I'm just finding the determinant of the matrix 3, 1, 2, minus 4. There you go. So I've written that ready for use. And if I picked another one, let's go to the bottom middle here. Then again, I'd be crossing stuff out. And I've now got 3, 1, 4, 6. That's my minor, and I'm going to find the determinant of that. So I've put them in that format because that's called the matrix of minors, so we can all see them. And then we're going to just modify that a bit to find what's called the matrix of cofactors. So everything in these determinants here is exactly the same, but we've got to deal with this plus minus issue that we saw before earlier. And again, we're changing the signs plus minus, alternating as we go across the rows, so the columns, and down the rows. And if it was a 4x4, we'd do exactly the same thing. We'd just carry on the pattern. Yeah, and we'd carry on this idea of the determinants as well. So this method is a general method. So there we are with that. Let's work out the values. Straightforward finding the values using the determinant method that we've had today. So if I look at the top left, I've got find the determinant up here top left. I've got 5 times minus 4, take away 6 times 10, so that's minus 20, plus 60 gives me plus 40. Thing I do need to watch out for is the ones with the negative sign. So let's have a look at the second one here, the 28. So if I've got 4 times minus 4, so that's minus 16, take away 6 times 2 is minus 12, so I've got minus 28. But it says change the sign, so I make that a plus 28. And I go around finding all these determinants, and I just make sure that I change the signs on these odd ones here. And I've got what we call the matrix of cofactors, often written with a C there, just called C for the cofactors. Yeah, this is what they're using in Edexcel, so I'm focusing on that, and that's what I'm teaching. Okay, so next thing is we're going to transpose this cofactors matrix. So what does that mean? Well, it means we're going to reflect it in this leading diagonal. So that means that the 4, minus 14 and 7 coefficients stay the same, and the others are swapped over because we're doing a reflection, yeah, transposing. So the minus 2 and the 28 were swapped, the 7 and the minus 50 were swapped, and the minus 14 and the 34 were swapped. And once we've done that, we've now got we're pretty well done with what's going inside the matrix of the inverse. The last thing we have to do, as we did with a 2 by 2, is multiply the whole thing by 1 over the determinant. So there we are, 1 over 26, 1 over 126, yeah? And now we've got an inverse matrix. So let's just summarize where we are. This process only finds an inverse if the determinant is not equal to 0. I'll come on to that in part 2 as to what that means if the determinant is 0. So what we're going to do, each time we're going to find the determinant, we're then going to find the matrix of minors, We're going to find the cofactor matrix by changing the signs. We're then going to transpose the cofactor matrix, and we're going to multiply it by 1 over the determinant. And that gives us the inverse matrix for a 3 by 3, a 4 by 4, or a 5 by 5, whatever you want. Best of luck.